Electronic ballasts can generate electromagnetic interference, also known as EMI, which can affect nearby electronic devices such as televisions and radios. It is important to ensure that all fixtures and wiring are properly grounded to eliminate potential EMI sources. Begin by inspecting the ballast wiring. Check that the ballasts are wired correctly and that no loose connections exist. If possible, try replacing one ballast at a time to see if the interference issue disappears. If replacing the ballast does not resolve the issue, consider installing an EMI filter. An EMI input line filter is installed between the power source and the ballast. An EMI output line filter is installed between the ballast and the lighting fixture. You can acquire EMI filters at electrical supply stores, lighting manufacturers, and online retailers. Consider using shielded wiring between the ballast and the light fixture to help reduce EMI. Ensure that all fixtures have a dedicated ground wire properly connected to the electrical panel. Try moving the lighting fixtures further away from the affected electronic devices. If the troubleshooting steps and filter installation do not resolve the interference issue, it is recommended to consult with a licensed electrician to investigate further and determine other potential sources of EMI. Understanding electromagnetic interference, or EMI, is crucial when dealing with electronic devices, especially lighting systems using electronic ballasts. EMI is essentially unwanted electromagnetic energy that can disrupt the operation of other electronic devices. This interference can manifest in various ways, such as static on radios, lines on television screens, or general performance issues with sensitive equipment. Several factors contribute to EMI generated by electronic ballasts. Firstly, the rapid switching of electronic components within the ballast creates high-frequency noise. This noise can radiate through the air or travel along electrical wiring, affecting nearby devices. Secondly, the design and quality of the ballast itself play a significant role. Poorly designed ballasts may lack adequate shielding or filtering, allowing more EMI to escape. Thirdly, the installation and grounding of the lighting fixtures can impact EMI levels. Improper grounding can create ground loops, which act as antennas, radiating EMI more effectively. Addressing EMI issues requires a systematic approach. Firstly, ensure proper grounding of all lighting fixtures and electrical wiring. Grounding provides a path for unwanted electrical noise to dissipate, reducing EMI. Check that all ground connections are secure and meet electrical code requirements. Secondly, inspect the wiring connections to the ballasts. Loose or corroded connections can create electrical noise and increase EMI. Tighten all connections and ensure they are clean and free of corrosion. Thirdly, consider replacing the ballasts with models that are specifically designed to minimize EMI. Look for ballasts that have built-in filters and shielding. These ballasts are typically more expensive, but they can significantly reduce EMI levels. Fourthly, install EMI filters at the power source or at the lighting fixtures. EMI filters are designed to block high-frequency noise from entering or exiting the device. Input line filters are installed between the power source and the ballast, while output line filters are installed between the ballast and the lighting fixture. Choose filters that are appropriate for the voltage and current requirements of the lighting system. Fifthly, use shielded wiring for the connections between the ballast and the lighting fixtures. Shielded wiring has a conductive layer that surrounds the wires, blocking EMI from radiating. Ensure that the shield is properly grounded to maximize its effectiveness. Sixthly, try relocating the lighting fixtures or the affected electronic devices. Increasing the distance between the source of EMI and the affected device can reduce the interference. Experiment with different placements to find the optimal configuration. If these measures do not resolve the EMI issue, consult with a qualified electrician or EMI specialist. They have the expertise and equipment to diagnose and mitigate complex EMI problems. They may recommend additional shielding, filtering, or grounding solutions. Understanding the different types of EMI filters is essential for effective mitigation. Common mode chokes are used to suppress common mode noise, which is noise that is present on both the line and neutral conductors. Differential mode chokes are used to suppress differential mode noise, which is noise that is present between the line and neutral conductors. Capacitor filters are used to block high-frequency noise by providing a low-impedance path to ground. Ferrite beads are used to absorb high-frequency noise by converting it into heat. The choice of filter depends on the type and frequency of the EMI being generated. Consider the characteristics of the lighting system and the sensitivity of the affected electronic devices when selecting an EMI filter. Proper installation of EMI filters is crucial for their effectiveness. Follow the manufacturer's instructions carefully. Ensure that the filter is properly grounded and that the connections are secure. Incorrect installation can render the filter ineffective or even create a safety hazard. Shielded wiring is another effective way to reduce EMI. Shielded cables have a conductive layer that surrounds the wires, blocking EMI from radiating. The shield must be properly grounded to be effective. Use shielded connectors to maintain the integrity of the shield throughout the wiring system. Grounding is a fundamental aspect of EMI mitigation. A properly grounded system provides a low impedance path for unwanted electrical noise to dissipate. Ensure that all lighting fixtures, electrical wiring, and equipment are properly grounded according to electrical code requirements. Check ground connections regularly to ensure they are secure and free of corrosion. In addition to these technical measures, consider other factors that can contribute to EMI. Power quality issues, such as voltage fluctuations and harmonic distortion, can exacerbate EMI problems. Install power conditioning equipment to stabilize the voltage and reduce harmonic distortion. Electromagnetic compatibility, or EMC, is the ability of electronic equipment to function correctly in its electromagnetic environment without causing interference to other equipment. EMC testing is used to ensure that equipment meets EMC standards. Consider EMC compliance when selecting lighting fixtures and other electronic devices. Regular maintenance of lighting systems can help prevent EMI problems. Inspect ballasts, wiring, and connections regularly. Replace worn or damaged components promptly. Keep lighting fixtures clean and free of dust and debris. By following these guidelines, you can effectively mitigate EMI from electronic ballast and ensure the proper operation of electronic devices. EMI, or electromagnetic interference, is a common issue when dealing with electronic devices, including lighting systems. It occurs when unwanted electromagnetic energy disrupts the operation of other electronic devices, causing problems such as static on radios, lines on television screens, or general performance issues. Understanding the sources of EMI is the first step in addressing the problem. Electronic ballasts, which are used to power fluorescent and LED lights, are a common source of EMI. The rapid switching of electronic components within the ballast generates high-frequency noise that can radiate through the air or travel along electrical wiring. Other potential sources of EMI include power supplies, motors, and electronic equipment. Several factors can influence the level of EMI generated by a device. The design and quality of the device play a significant role. Poorly designed devices may lack adequate shielding or filtering, allowing more EMI to escape. The installation and grounding of the device can also impact EMI levels. Improper grounding can create ground loops, which act as antennas, radiating EMI more effectively. Addressing EMI issues requires a systematic approach. Start by identifying the source of the EMI. This can be done by observing which devices are affected and when the interference occurs. Once the source is identified, take steps to reduce the EMI levels. One of the most effective ways to reduce EMI is to improve the grounding of the system. Ensure that all devices are properly grounded according to electrical code requirements. Check that ground connections are secure and free of corrosion. Another way to reduce EMI is to install EMI filters. EMI filters are designed to block high-frequency noise from entering or exiting a device. They are available in a variety of types, including input line filters, output line filters, and power line filters. The choice of filter depends on the type and frequency of the EMI being generated. Shielded wiring can also be used to reduce EMI. Shielded cables have a conductive layer that surrounds the wires, blocking EMI from radiating. The shield must be properly grounded to be effective. In addition to these technical measures, consider other factors that can contribute to EMI. Power quality issues, such as voltage fluctuations and harmonic distortion, can exacerbate EMI problems. Install power conditioning equipment to stabilize the voltage and reduce harmonic distortion. Electromagnetic compatibility, or EMC, is the ability of electronic equipment to function correctly in its electromagnetic environment without causing interference to other equipment. EMC testing is used to ensure that equipment meets EMC standards. Consider EMC compliance when selecting lighting fixtures and other electronic devices. Regular maintenance of lighting systems can help prevent EMI problems. Inspect ballast, wiring, and connections regularly. Replace worn or damaged components promptly. Keep lighting fixtures clean and free of dust and debris. By following these guidelines, you can effectively mitigate EMI and ensure the proper operation of electronic devices. Electromagnetic interference from lighting fixtures can be a frustrating issue, disrupting the performance of sensitive electronic equipment. Understanding the causes of this interference and implementing effective solutions are crucial for maintaining a stable and reliable electronic environment. Firstly, it's important to recognize that electronic ballasts used in fluorescent and LED lighting fixtures are a primary source of electromagnetic interference. These ballasts operate by rapidly switching electrical current, generating high-frequency noise that can radiate through the air or travel along electrical wiring. This noise can interfere with the operation of nearby electronic devices, causing problems such as static on radios, lines on television screens, and malfunctioning electronic equipment. Secondly, the quality and design of the lighting fixtures and ballasts play a significant role in the level of electromagnetic interference produced. Poorly designed or manufactured ballasts may lack adequate shielding or filtering, allowing more noise to escape into the surrounding environment. Similarly, unshielded or poorly shielded lighting fixtures can act as antennas, radiating electromagnetic interference more effectively. Thirdly, the wiring and grounding of the lighting system can also contribute to electromagnetic interference. Improperly grounded fixtures or wiring can create ground loops, which can amplify and radiate electromagnetic noise. Loose or corroded connections can also generate noise and increase the overall level of electromagnetic interference. To mitigate electromagnetic interference from lighting fixtures, several strategies can be employed. Firstly, ensure that all lighting fixtures are properly grounded according to electrical code requirements. Grounding provides a path for unwanted electrical noise to dissipate, reducing the amount of interference that radiates into the surrounding environment. Secondly, use high-quality lighting fixtures and ballasts that are designed to minimize electromagnetic interference. Look for ballasts that have built-in filters and shielding, and choose fixtures that are constructed with shielded materials. Thirdly, consider using shielded wiring for the connections between the ballasts and the lighting fixtures. Shielded cables have a conductive layer that surrounds the wires, blocking electromagnetic interference from radiating. Ensure that the shield is properly grounded to maximize its effectiveness. Fourthly, install electromagnetic interference filters at the power source or at the lighting fixtures. These filters are designed to block high-frequency noise from entering or exiting the device, reducing the amount of interference that reaches sensitive electronic equipment. Fifthly, try to physically separate the lighting fixtures from sensitive electronic equipment. Increasing the distance between the source of electromagnetic interference and the affected devices can reduce the amount of interference that reaches them. Sixthly, consider using power conditioning equipment to improve the quality of the electrical power supply. Power conditioning equipment can filter out noise and voltage fluctuations, reducing the overall level of electromagnetic interference in the electrical system. Seventhly, regular maintenance of the lighting system can help prevent electromagnetic interference problems. Inspect ballasts, wiring, and connections regularly and replace worn or damaged components promptly. By implementing these strategies, you can effectively mitigate electromagnetic interference from lighting fixtures and ensure the proper operation of sensitive electronic equipment. Remember that addressing electromagnetic interference issues may require a combination of approaches, and it's often helpful to consult with a qualified electrician or electromagnetic compatibility specialist to identify the best solutions for your specific situation. Always prioritize safety when working with electrical systems, and follow all applicable electrical codes and regulations. Mitigating electromagnetic interference (EMI) from lighting requires a multifaceted approach, combining best practices in installation, component selection, and shielding techniques. Understanding the source and path of the interference is crucial for effective mitigation. Firstly, the electronic ballasts themselves are often the primary source of EMI in lighting systems. These devices switch current rapidly to drive the lamps, generating high-frequency noise that can propagate through the power lines and radiate into the surrounding space. Secondly, the wiring and grounding within the lighting system can act as pathways for EMI to spread. Poorly shielded or improperly grounded wiring can radiate noise, while ground loops can create circulating currents that amplify interference. Thirdly, the building structure and nearby equipment can also play a role in EMI propagation. Metal conduits, building wiring, and electronic devices can all act as antennas, radiating or conducting EMI. To minimize EMI from lighting, consider the following strategies. Firstly, choose electronic ballasts with built-in EMI filtering and shielding. These ballasts are designed to suppress the generation and radiation of high-frequency noise. Look for ballasts that comply with relevant EMI standards and regulations. Secondly, use shielded wiring for all connections within the lighting system. Shielded cables have a conductive layer that surrounds the wires, blocking EMI from radiating. Ensure that the shield is properly grounded to maximize its effectiveness. Thirdly, implement proper grounding techniques throughout the lighting system. Ground all metal enclosures, conduits, and equipment to provide a low impedance path for EMI to dissipate. Avoid creating ground loops by using a single point grounding system. Fourthly, install EMI filters at the power input to the lighting system. These filters can block high-frequency noise from entering the system and propagating through the wiring. Fifthly, physically separate the lighting fixtures from sensitive electronic equipment. Increasing the distance between the source of EMI and the affected devices can reduce the level of interference. Sixthly, use metal conduit to enclose the wiring in the lighting system. Metal conduit provides shielding that can block EMI from radiating. Seventhly, consider using ferrite beads on the wiring in the lighting system. Ferrite beads are small, cylindrical components that can absorb high-frequency noise. They can be placed in the wiring near the ballasts or other sources of EMI. Eighthly, ensure that the building's electrical system is properly grounded and that there are no ground loops. Ground loops can create circulating currents that amplify EMI. Ninthly, consult with an electrician or EMI specialist to assess the lighting system and identify potential sources of EMI. They can recommend specific mitigation techniques based on the specific characteristics of the system and the surrounding environment. Tenthly, regularly inspect and maintain the lighting system to ensure that all components are functioning properly and that there are no loose connections or damaged wiring. By implementing these strategies, you can effectively mitigate EMI from lighting and ensure the proper operation of sensitive electronic equipment. Remember that EMI mitigation may require a combination of approaches, and it's often helpful to consult with experts to determine the best solutions for your specific situation.